Hello and welcome back to Microbit Mondays. Last week we looked at the ability of microbits to send messages to each other over the radio, as it's called. This week, in our final part for now, we're going to look at one of the other really interesting features of the microbit, which is the ability to connect other objects and electrical components and have these control and be controlled by the code we write. Now eventually this could be things like motors, flashing multicoloured lights enabling us to build robots and all sorts of fun contraptions, with the microbit acting as our central brain. But for now, let's look at connecting up something we've got to hand, like our own bodies. So we're going to be using these what are called pins at the bottom of the microbit here. We have 3 here, 0, 1, 2, and we also have this 3V and ground pin, which we'll come to soon. Now, the code we've got loaded on here at the moment is fairly simple. All it does is display this small picture of a heart, and when it detects that pin 0 has been pressed down, it turns it into a large heart. Now, to do this, we need to press down on the ground pin and press down on pin 0 at the same time. There we go. This works slightly differently to the buttons we've used before. What you're actually doing is completing a circuit. By holding down the ground pin and pressing on pin 0, it's actually completing a circuit. So in a way, the electricity is flowing through your body, completing a circuit. The microbit's detecting that and displaying the picture of the large heart. Now you can do this by just touching the pins, as we've seen, though that doesn't always work reliably all the time. The best way to do it, and the way we're going to connect other things up, is by using these things here called crocodile clips. Now these are fairly cheap and easily available online. I'll put a link in the description where you can get them from. But what we do is we take one end of the crocodile clip and we can connect it up to one of these pins on the bottom of the microbit here. So you just press down to open up the jaws and then just clip it on simply where the holes are, like that. So I'll put one on the ground pin and then I'll put another one here on pin 0, just like that. And now I can touch the ends of these crocodile clips, which are made of metal, to make the same thing happen. One there and one there, and you can see we get the large heart. It's worth pointing out as well, while we're on the subject, that this is completely harmless. There's no need to worry. The amount of electricity that's flowing through our bodies is tiny and can't harm us in any way. So before we move on and connect some other stuff up, let's just have a quick look at the code here. Now this works in a broadly similar way to the way we've done things in previous weeks. We're detecting a press here and then doing something when it detects that thing has been pressed. It's slightly different though. Over in our input section here, we do have a on pin 0 pressed block we could use, and that would work in pretty much the exact same way as one of the button presses we've used before. But we're doing this very slightly differently. What we're doing is using this while loop, and that lives in the loop sections here, which you may remember we've got things from before, like the repeat 4 times. So basically what this while loop is doing is testing a condition. The condition we've given it is pin 0 pressed, and that's just come from our input section over here. We've got button A is pressed and we've also got pin is pressed. So all it's saying is while this condition is true, pin 0 is pressed, I want you to do something. In this case, show the large heart icon, and whether that's not true anymore, so as soon as we let go of the pin, we're going to show the small heart icon. So this is useful because now we can implement what we call momentary button presses, where something happens only as long as that particular thing is held down. We can of course test this on the simulator just like with everything else. I can press this pin 0 here to show the large heart. As soon as I let go, it shows the small heart again. Now of course in real life, as we demonstrated, to make this work we need to be holding onto the ground pin and press down on pin 0, because remember, we're completing a circuit. Now interestingly, this will even work with 2 people. If one person holds one connector, another person holds the other connector, and then they touch hands or touch fingers, that will also complete the circuit and make something happen. So now that we've got our crocodile clips connected up to our microbit, we can connect these up to other things and use them as touch sensors as well. Now fruit, surprisingly, is actually a really good choice for this because it has a high moisture content. So what I'm going to do is take this banana here and connect the other end of the crocodile clip, not the one that's connected to the microbit, up to this banana here. Just clip it on the end like that. And now if I hold down this end, the other crocodile clip, and touch the banana, you should be able to see that it detects it in the exact same way as when we touch the pin directly. Now I could of course take this lemon and connect it up to the other crocodile clip. Just slot that on there. Now if I touch the lemon and the banana at the same time, we can see the heart changes because again, we've completed the circuit. So we've looked at making our microbit respond to an input with something connected. Now let's look at getting the microbit to control something that we connect up. Let's use something that most of us have lying around somewhere, a pair of headphones, and get our microbit to play some sweet tunes for us. So what I'm going to do to get started is, with the plug end of a set of headphones, I'm going to take the crocodile clip that's connected to the ground pin on our microbit and connect that to that end of the plug there, and then with the other crocodile clip that's connected up to our pin 0, I'm going to put that on the very tip of our plug on our headphones. So now back in our code editor, we can see that the code for this is actually fairly simple. We're responding to button presses again, simple button presses, and each time we press a button we're simply going to play a different tone, a different melody. Now these all come from this music section over here. You can see there's a whole bunch of different things. We can test these out in the simulator as well. So if we press button A, we should get this. Now all this is doing is playing one tone, i.e. one note, for an amount of time we give it, 1 beat, half a beat. These are kind of musical terms. Don't worry too much about what they mean if you don't know, just play around and have fun figuring it out. When button B is pressed, we've actually got some built-in melodies we can select. So if we click this little drop down here, there's a whole bunch of different ones we can pick from. So if we press button B, we should get a little tune played for us. And then we've also got this third block here, which remember just comes from the section over here, this play melody, where we can click in here and even draw our own little melody in, compose our own tunes. And then with your code loaded onto your microbit and a set of headphones connected up like I showed you how to do in a moment ago, you'll be able to try this out in real life as well. Now we could easily combine the two ideas we've looked at today to have two different pieces of fruit play two different melodies. So we now have both inputs and outputs coming from our microbit. The code, as we can see, is actually very simple. We're just saying on pin 1 pressed, play this melody, and then on pin 2 pressed, play a different melody. We just need to wire a few more things up. So this might look like a whole load of really complicated wiring, but in fact it's actually quite simple. We've still got our headphone connector wired up in exactly the same way before. This green one is going to the ground connector on our microbit, and this yellow one from the tip of the connector is going to pin 0. And then just like when we used some fruit before, I've got the red connector going to pin 1, and that's connected up to our banana, and then the white connector is connected up to pin 2, and that's going over to our lemon. And now just like before, by completing the circuit, which I'm going to do by just touching this ground connector that's connected up to the microbit with the green cable, and then pressing our banana, we will get one melody. And then by touching the lemon, we'll get a different one. Now let's look at something maybe a little more useful and use inputs to get our microbit to monitor the moisture level in a potted plant, and in this way know when it needs watering. Now what this code is doing is setting a variable we've made to be something just like we've done before, and that thing is the analog read of pin 0. Now that comes from our advanced section down here, and in our pins here we can see we've got this analog read pin 0. So what is that, you might ask? Well, it's going to be a different amount depending on how wet our soil is. It's not a simple on-off like we've had with button presses before. Now this would be a number that we could just print to the screen, but let's go ahead and turn it straight into a bar graph like we did last week when we played the game of hide and seek. And that's what this bit of code here is about. It's going to take this reading of the analog value of pin 0 and turn it into a bar graph. You may be wondering why we've put this value of 1023 in here. That's because if we go into the help function, which I'm going to do by right clicking on analog read and clicking help, it tells us here that this returns, i.e. it gives us a number from 0 to 1023. If you're ever in a little bit of doubt as to exactly what one of the bits of code does, you can always right click on it and use that help to help you figure stuff out. So to test this out in real life, what I'm going to do is use the crocodile clips again. Now just like before, one is connected up to pin 0 here on the microbit, but the other one I've connected up to the 3V connector, which is the one next to the ground connector. And what I'm going to do is just take some screws or bolts, anything like that. You could use screws, bolts, anything made of metal basically that you've got lying around that we can poke into the soil on the plant. And I'm just going to take one of these crocodile clips and connect it up to one of the bolts, and take the other one and connect it up to the other one. And basically what happens here is the wetter the soil is, the more electricity is conducted and the higher the reading will be, filling up more of the screen. You can see here, if I put it in this particular pot plant that is in the bathroom, it's quite moist and damp in there. We pretty much get a full reading on the screen, so that means that soil's very wet. Whereas I try it with this cactus, which has much drier soil, it only fills about half the screen up. But maybe we don't want to take readings all the time though, especially as this will use a lot of power and drain the battery if we're using one. So let's change our code so that it only takes a reading when we press a button. So this code is quite similar to things we've done before. We're using this while loop again, just like we did earlier on. What we're saying is while button A is pressed, this is when we're going to take our reading. And what we're going to do is use analog write, which is kind of the opposite to the analog read we've used before, to set pin 0 to be 1023, which you might remember is the maximum value it can be. Now that's exactly the same as using our 3V pin before, except we're only turning it on for as long as we need to take the reading. And this is exactly what this is doing. When we press button A, and only as long as we've got button A held down, we do an analog write of pin 1 to make that be maximum. That gives the power so that we can do a reading on pin 0. And then as soon as we've taken this reading by setting this variable to be the analog read, we put pin 1 to be 0 again, which is the same as turning it off. So you can think of it, button A is pressed, pin 1 is turned on, pin 0 does our reading of how wet the soil is, and then pin 1 is turned off again straight away. So we only use a tiny amount of power. And again, the bar graph is only plotted on the screen as long as that button A is held down. When button A is not held down, we can even clear the screen, so very little power is actually being used. And you can see now here in real life, in this example, we only get a reading when I hold down the button. Now you could easily modify this code to do all sorts of interesting things using the techniques we learned in previous weeks. Maybe it takes a reading every 10 seconds or so by using the pause function, or you could use an if block to test when the reading goes below a certain amount and then display a message like I'm thirsty. Maybe even then send that message to another microbit somewhere else in the house. There are many possibilities, but I'll leave that up to you for now. The best way to learn is just to have a go, have a play, and see what you can come up with. So that's it for now. I hope you enjoyed this short introduction to microbits and some of the fun things you can do with them. Let us know if you'd like to see any more videos like this, because there's lots more we can explore yet. But bye for now.